Yeah, hello everyone. It's awesome to see so many. This talk is about Java EE. Who is an enterprise developer here? Few, excellent. Who is already using EE7? One, okay. So I thought I'd first introduce myself. My name is Hardy. I'm a member of the Hibernate team for quite a few years. I'm the project lead of Hibernate Validator, which is the reference implementation of Bean Validation, which is part of EE7. So that's, of course, the reason why I'm focusing on that part specifically. I'm also part of the expert group for Bean Validation 1.1 and was also a little bit involved in CDI 1.1 and how it integrates into the whole EE7 platform. What are we going to talk about? I want to kind of give a little bit an overview about EE7 and what's new, what were the plans, and then I kind of deep dive or kind of go deeper into Bean Validation and CDI. It's in both cases just a .1 release or upgrade. And hopefully we have some time for looking at some code, some tips and tricks. If possible, I would like to talk about portable extensions, which is a very powerful way to extend CDI. And CDI is or has become like some sort of glue which holds together the whole platform. So this picture shows what's new in Java EE7. Who knows what's not part of EE7, which should have been part of it? No one? So part of EE7 was supposed to kind of come up with a unified cloud API. That just did not happen. There was basically no agreement on how this should look like. It was too early to standardize on something. So instead of kind of moving out the release of EE7, which happened now this year in March, they basically said, look, we have to get EE7 out and we're moving the cloud API into EE8. But what's new in EE7? There are kind of these three pillars which kind of Oracle drew up. If you look at the right-hand side first, there's this batch API. That's a completely new API. It allows you to do batch processing. It's pretty much based on Spring Batch. I've myself never used it. Just heard, basically. Then there's concurrency tools. I think that was a very important improvement in the platform. The problem here was really that, say you deploy an application, and in your application you're doing multi-threading, and you kind of maintain all these threads and the execution services and whatnot all yourself. What happens if your application crashes or the container or whatever? Who cleans that up? It's because you are in charge of it, potentially it does not get properly cleaned up. So that was the reason why now, via JNDI, you can, in your EE7 application, get something like a default manager execution service, and you can let the container take care of your multi-threading. So you kind of give the extra runnables or the task you want to execute to the container, and the container is responsible for running or maintaining this thread pool or this executor service. Simplified JMS. Who has done something with JMS in EE6 or in general? A few. The API was really terrible, a lot of boilerplate code. You had to look up factories and create the queues and messages, and that's all gone. You can inject JMS context, and you go JMS context, get producer, set message, off you go. Like all the boilerplate code is gone. And here's already one point where this CDI comes in. Kind of, as I said, it's kind of this connecting glue now. And now you can just inject a JMS context. You don't have to kind of look it up and write boilerplate code to get hold of this object. Just inject it, use it, send your message. But I'm not kind of going deeper into this thing. Then the big block, of course, is HTML5. There are a whole bunch of features like WebSocket, JSON, REST, Servlet 3.1, which is just an upgrade. But WebSockets, JSON, and REST, they're basically new. All there to kind of get HTML5 into the EE7 specification. And then on the left side, we kind of see what these small little things which kind of are improved or got improved in EE7. And that's a little bit what I already kind of mentioned with JMS, that this boilerplate code is gone. The idea is kind of make it even easier for the developers to use the platform. I don't want to write all this boilerplate code. I kind of want to just inject what I need and kind of directly execute the methods on these objects. And this idea of let's try to combine these different components even tighter. So if you look at the different specifications, I think there's 33 specifications which are part of EE7. And this kind of picture lists them all out. And the orange ones, these are the new kind of specification or new features, whereas everything else is basically just upgrades or kind of small changes. Interestingly, that's, I think, like Bean validation is kind of vertically in this picture because that's one of the specifications which applies on all kind of tiers. On the front end, on the data level, it integrates with JPA, with JSF, on all sorts of levels. That's one of the reasons why I think it's a quite interesting specification to look at because it integrates with so many other things. And of course, CDI and CDI extensions, which kind of also hold a lot of these things together. Bean validation 1.1. So what's new there? What has changed? I just want to kind of recapitulate what is Bean validation. Who knows what Bean validation is? That's basically who has not seen this type of constraints yet or this kind of type of annotations. Okay, a few. So the idea basically is that you need to validate your data at different levels. You can do that in the front end, or you can in JavaScript. You can do it when you kind of get the HTTP request. You can do that in the data level on your domain objects, on all sorts of levels. And the idea behind Bean validation is to kind of capture this, and instead of doing validation all sorts of different levels in different programming languages, duplicating code, duplicating validation, you're doing it once, and you kind of do it declaratively via annotations. You're saying, now there's a class name, first name, last name, and you basically just say, when I validate an instance of name, the first name cannot be null and has to be between 1 and 16 characters, and the same for the last name. And I mean, everyone who kind of know Bean validation 1.0 in general, the specification comes with a whole bunch of built-in constraints you can use out of the box on your domain objects. Or, of course, you can write your own. There's an API to write your own constraints. It's a little bit small, maybe. This is basically just what I tried to explain. There's different layers in the application. Each kind of needs, to a certain degree, validation. And the idea behind Bean validation is collect these validation rules in the domain model at one single point and validate it there and write the logic to validate it only once. So Bean validation is a uniform way to express validation rules. It's centered around your domain model, and it has a type-safe and generic API to execute or to validate, and a powerful metadata API, so you can kind of ask, there's a validator instance, and you can ask this validator instance, give me the constraints for a given class. And then you kind of get a descriptor back, and you can kind of iterate or go through this descriptor to find out what are the constraints on this domain instance or on domain class. If you have any questions, you kind of just raise your hands. So that was Bean validation 1.0. Who uses Bean validation? Everyone has seen it. Great. So now Bean validation 1.1. And before I go into the features of Bean validation 1.1, I want to point out something different, which I think is really special about Bean validation and, in fact, about CDI. Both specifications are led by Red Hat. And the idea is, who has tried before to kind of get some information on how something works via a specification, kind of go and download the specification and try to understand how this works? No one? You should. It's actually, the specifications have sometimes really good examples to understand the technology. The problem is that a lot of specifications, if you're lucky, you're able to get the PDF version of the specification. If you're not so lucky, you don't even find that. And the nice thing about Bean validation is that everything is in the open. There is a website, beanvalidation.org. It has all the pointers to the right resources. And even more interestingly, everything is open source. Everything is available. You have the implementation, Hibernate Validator, as reference implementation of the specification. You have the TCK. You can download the TCK and kind of try to run it or use the examples in there. The specification and even the website is all open sourced, and you can look at it and play with it. Especially, I think that the TCK is available is a big bonus. Try to get the TCK for JPA, it's basically impossible. Anyway, so what's new in Bean Validation 1.1? So there are four main things. There is expression language in the message interpolation, group conversion, improved CDI integration, and method and constructor validation. And I kind of try to explain each of them a little bit. So how things work in Bean validation is like you're using one of these constraints like decimal min, and if you then validate an entity or instance which has this constraint on it, and there's a validation error, you're kind of getting an error, a constraint validation exception with an error message. And in case of decimal min, the error messages must be greater than or equal to value, and value is the value you're kind of trying to validate. So now someone asked or said when we kind of were talking about the new specification, it would be very nice with decimal min and max to have something like inclusive false true, because that kind of allows me to kind of specify an upper or lower limit for my decimal range, which is our problem was then we said like, yeah, that makes sense. We want to have this flag, but what happens if this constraint fails? Our error messages were kind of just strings where I could replace the value, but really I have to change this message depending on if this flag is set or not. So there was a long discussion, do we have our own syntax for this kind of thing, or what are we going to do? And then we decided that we're using expression language, which is kind of known out of JSF, and use it also for interpolation of these error messages. So in this case, you can see here now like the $sign that starts expression language expression. And here we're saying exclusive equals true. So if this flag is set, then you're kind of adding the string or equal to. And if the flag is false, it's the empty string. So now you can basically have this, these kind of operators in your messages. And kind of driven was this by this whole idea of or this decimal min-max, partly at least. There's also something bound into the context of the interpolator, which is called formatter. Behaves exactly like string.format, and allows me to kind of format in this printf syntax where I use %s and then the format strings. Validated value is also now available as an object in this expression language, and you can kind of navigate the properties similar to like this dot notation, like validated value.h in case it would be a person, for example, with an h, or then formatter.format. The other big feature or change is group conversion. So if you have, for example, here like this rental car, and you're validating a rental car, there is this concept of cascading validation. So rental car has a driver. And I want to make sure that when I validate the rental car, my driver instance gets also validated. And that's normally, or in Bean Validation 1.0, this was expressed with the addValid annotation. The problem here was Bean Validation also has a concept of groups. So if you don't specify a group, it's something like the default group, and all the constraints belong to the default group. But you can also kind of take a constraint and place it or give it a given group. So like in the driver instance, we have driver checks, the group drivers checks. So what happens if I validate my rental car instance in the default group, and I only want to target in the cascaded validation the has license of the driver? I don't care about the other constraints on the driver. I just want to make sure that this guy has a driver license. I could not really express that because addValid basically just said, okay, validate this reference and in the default group, because rental car is validated in the default group. And that's where the convert group came in now. You can basically say, if rental car is validated in the default group, and you kind of, I'm kind of crossing the boundary to driver, then driver checks should be validated. And this annotation is only available, or you can only use it in combination with add valid. You cannot, if there's no add valid, it's not going to work. You get an exception. But this basically allows you to change groups at the boundaries of objects. Also kind of handy if you have, maybe you're kind of using a reference to another class which is not in your control. It's kind of part of a different library, also using constraints. And you can't change that, you can't make it part of the same groups you're using. Then you could use default convert group to kind of use the right group from this other library. It was one of the features which was heavily requested by people. Coming back to CDI integration, I think I mentioned that now many times, that things are kind of getting tied together. So what happens there was Bean Validation has several things where you can kind of configure how your validator works or behaves, like a message interpolator, a traversable resolver, a parameter name provider. I don't want to go into details what they all mean. Interestingly, also constraint validators. That's something you as user might get in contact with when you write your own constraints. And before, in EE6, these kind of instances, even though they were created by in your container, in your EE6 container, you could not use inject on it. You could not inject a resource into your constraint validator implementation. I should show an example. So this is an example for a custom constraint. There's a greeting constraint, whatever that is. And now you can just use add inject greeter or whatever resource you want to inject, and you need to kind of initialize your constraint, or your constraint validator, I should say. And this was not possible. This kind of customization of Bean validation were kind of bypassing CDI, and you could not use this kind of really nice way of injecting things. And now we come to the biggest new thing in Bean validation, which is method validation. So all we did so far was putting these constraints on the properties of a class, of a type, either on the fields themselves or on the getters. And what we did now in Bean Validation 1.1 is we added method validation. And I don't know, I guess there are different names for this, contract programming, design by contract, and so on. The idea is basically that you define pre- and post-conditions for your methods. So you're not validating a state of a type, but like the parameters of a method call or the return value of a method call. And this is now possible. It was not possible in Bean Validation 1.0. So in this case, we have a place order method, which has a customer code, and this customer code cannot be null, and it has to be between 3 and 20 characters. And the item which gets placed can also not be null, and add valid basically say, take this item and validate the state of this item. And then in the return value, the order instance returned cannot be null, and it has to be valid. Again, the returned object, the state of the returned object must pass all the validation rules. So that's the biggest new feature in Bean validation. Within your container, as soon as you start placing constraints on methods like this, it will automatically start method validation. You don't have to configure anything. You don't have to write configuration files. Just placing annotations on methods will kind of trigger method validation in a EE7 environment. There's also something called cross-parameter constraints, which is a little bit tricky. So in this case, what we saw here was I put in constraints on a single parameter. But what do I do if my constraint has to validate something like a dependency between two parameters? An example would be password and password confirmations. I have to match. I can't kind of place that really properly somewhere. So the solution we came up with was to kind of place it on the method, like password match. But that's a little bit problematic. Who sees why that could be problematic? No one. In this case, it's easy. This method returns void. So whatever, this password match constraint has to kind of target these two parameters. what if this method would return something? And it would be called get something. Then we have a problem at, it could be a bean validation, like a state validation, or it could be a method validation. And that's actually really a problem. And to kind of address that, there's a new annotation you have to place onto your implementation of a constraint validator, and that's supported validation target. And there you say, I'm targeting the parameters, or I'm targeting the return value, or you can target both. In most cases, we can derive it, and if it's a void method, yeah, no problem. If it's returns a value and is a getter, then we are looking at validation target parameters, supported validation target, and if that's still not unique, you basically get an exception saying we cannot decide, is this a getter or is this a cross-parameter constraint? Personally, I know it's a little bit unfortunate because by looking at the code you're writing, you cannot tell what this constraint is targeting. You have to see the implementation. It was a long discussion about, is this a good idea? Should we do that? Should we not do that? Do we need cross-parameter constraints? But in the end, this solution won. And the recommendation is here, if you have cross-parameter constraints, you should kind of try to encode in the name of your custom constraint that it kind of like password match for parameters or something like this, because it's not always clear. So this other thing which is now important to know, so there's an API, a types like there's a validator factory which creates a validator, and this kind of instance has methods for validate method, validate parameter, validate return value. It's called executable validator. You as a developer on EE7, you don't have to care about this low-level API. That's something like integrators and library providers should kind of care of. If you use EE7, you should be able to kind of just do this annotation thing and it's happening. And what's under the hood is going to happen is like you're the client, you're making a call to a method, and then there has to be some sort of interception technology in between which kind of takes this call and goes, hang on, there are constraints on the parameters. I better kind of validate the parameters first. If there's a problem, I throw an exception. If not, I kind of pass it down to the actional method, execute the method return value comes back, I kind of validate the return value, go, everything okay, I return to the client. So this kind of proxy layer, that's, sure, you can write it yourself in your library if you want to kind of do everything, but then you have to kind of come up with this proxy layer. It's either via interceptors, AOP, you name it. I mean, there are many technologies which kind of allow you to do that. In the case of EE7, again, that's CDI who does it, CDI interceptors, which kind of does this kind of proxying or interception call. Now we come to another interesting thing. Who has heard about the Liskov substitution principle? A few. Excellent. So the idea is, if I have polymorphism and classes, if I have a subclass and treat it as a pointer to a base class, the behavior should not change. So the classic example is a rectangle, and I derive a square from it. And say the rectangle has a method area. So if I have this square and I set the height, for example, then area is not behaving the same as in the rectangle, because in a square I also have to adjust the height. So it's like you're not supposed to do that. Like this object, this subclass has to behave in the same way as a parent class if it's kind of treated as a parent class. And that's kind of just the OO principle and I guess considered good programming. And the same, we kind of did a little bit of research and we looked around of this kind of methods interception frameworks, or this programming by contract frameworks. And basically all of these frameworks said, okay, we actually have to honor this also when we're kind of doing method validation. And in the case of method validation, that means you cannot kind of strengthen the preconditions of a method in a subclass. That means you cannot place additional constraints in in a method of a subclass or a method implementing an interface, because that would kind of strengthen, you would add additional constraints. If I then would have a pointer or reference to the interface or the base class and validate it, it would not behave, or potentially I would validate more constraints as if I would have like the parent or the base class. And then the other thing is post conditions cannot be weakened, which is not really an issue because we can't express that. We can't really take away constraints from, if I define them on a base class, there's no, I can't even take it away kind of programmatic, like via annotations or something like this. I have an example. So I have an interface foo, and it does do stuff, and there it gets a string as a parameter, and this string cannot be null. And then I have a class foobar which implements foo. I implement do stuff, and I kind of go, actually in my case I would like to also have size, minimum size of 3. That's not going to work. You cannot do that. We get the constraint declaration exception. According to Liskov, or according to the rules in the specification now, you have to do this. You have to, either you don't do the extra constraint, or you have to pull it up into the interface or into the base class. Which is maybe a tricky thing. I mean, there have been people who said like, why did you do that? Why, we just want to place, we don't want to care about inheritance and polymorphism, we just want to place constraints, and if there's a constraint, evaluate it, I deal with it. I guess we have to see what the use cases will be, and if there's a flag needed to kind of change the behavior. Okay, so that was a little bit Bean validation. Any questions to Bean validation? So basically we had 4 new features: this message interpolation, CDI integration, group conversion, and the biggest part, this method validation. I want to talk a little bit about CDI. CDI, again, a specification led by Red Hat, open source, same procedure, it has a website. So all the information you can get or want to get from CDI is on the website, reference implementation, TCK, everything. So what's new in CDI 1.1? So that's actually quite interesting. Like from a new feature point of view, there is actually not so much, but what has changed a lot is how much CDI integrates as a component. The JSF model got kind of aligned with CDI, JTA, transactional interceptor, got introduced, the whole JMS API got modernized via CDI. And as I just also said, like all these different components from Bean validation kind of are now kind of injectable, or you can use, you can inject into them. So this is, I think, that's the really big things in EE7 and CDI 1.1, this kind of tighter integration. There are also a couple of other things. So like now you can programmatically veto a bean. So who is using CDI? A few. So the idea here is that until 1.1, you were not able, if you had a bean archive and there were beans in there was no way to programmatically disable a bean and say, oh, for this deployment, I don't want it to be a managed bean. And now you can do that by placing add veto onto this bean. Another change is, which is kind of maybe a little bit a smaller one, you don't need Bean XML 1.0. You had to have Bean XML, otherwise it would not even be scanned for managed beans. Now you can leave Bean XML off, and things will still get scanned for managed beans. And then there's another new annotation called with annotations, which is part of process annotated type. And I come back to this one in my example. Another interesting thing is that there's a new specification which kind of got split out of AGB and CDI. And that's kind of interceptors. Now CDI had their interceptors. We had the AGB interceptors or callbacks. And the thing was like, again, let's combine that. Let's kind of get this out, have a common spec, and add this there. And then on top of these new specifications, there were 2 things which actually came a little bit out of the Bean validation camp. That's once add around construct, which allows you to intercept constructors. You couldn't do that in EE6. And now you can do that, and the need was for method validation. We not only want to intercept method calls, but also constructor calls. And that was not possible in EE6. And also, what also was not possible in CDI or in interceptors in EE6 was to kind of specify a clear order in which interceptors would kind of would occur or kind of trigger. And we kind of needed that to make sure, for method validation, that, okay, so the method comes in, I first want to do the parameter validation, then I want to call the method, and these kind of things. So we had to we needed a mechanism to kind of give the interceptors an order. And that you can do now with add priority. And the specification kind of has like a reserved range of priorities and kind of defines, okay, these are the priorities, the different components of CDI use. If you want to have other interceptors, you should kind of use these kind of range. Cool. Let's look at some code. So what I'm going to show now is a little bit some code we are using to actually, in the actual platform, so in Glass with the reference implementation of EE7, but also in Wildfly, in the JBoss application server, how we integrate Bean validation via CDI into the framework. And I'm hoping you kind of, what I want to show is like how easy you can customize Bean CDI. And there the core is really the Bean manager, how you kind of get hold of the Bean manager, how you can kind of register new beans or kind of add interceptor annotation binding, these kind of things. Who has used the extension or portable extension in CDI? No one. Okay, so sure. That's better, no? So what's a portable extension? So it's a class and it implements extensions. That's a marker interface. You don't have to implement a method in there. So I'm not sure if I have the source code attached there. No. So it's a pure marker interface. There is nothing you really have to implement. But what's happening is if you have a jar file or something you deploy into your container, you have to add a service file at the meta-inf services, and you kind of, the name of the file is enterprise inject SPI extension, and there you specify the fully qualified path of your implementation, of your portable extension. So if at boot time this kind of service file is found and it kind of goes to the extension, then you basically can hook into the CDI boot process. You kind of get hold of the Bean manager and you can do all sorts of things to customize your CDI environment. And a few things I would like to show you now. Let's see. Looking for the right spot. Okay, let's start with this one. Before Bean discovery, so that's a event. What you have to do is, like, the method name is actually irrelevant. What you have to do is you have to use the annotation @observe before Bean discovery. So that basically is one of the very first callbacks you can get from a CDI bootstrap. And the idea here was for us, how do we get this interceptor? Because as I said, you as a developer, you should be able to just place method constraints and they get automatically validated. So we have to kind of register an interceptor in the EE7 container. And to do that, we either would have to kind of create a Bean XML and kind of, that was a traditional way, and kind of specify the interceptor and the fully qualified class name. But in this case, what we did is we're using this before Bean discovery callback, and then programmatically go before Bean discovery event, add annotated type, and that's the validation interceptor. So you can programmatically add types to the bootstrap process. And they're getting processed as if they would be specified in Bean XML or in, and so on. So the other thing which is now interested is again, I've kind of mentioned with annotations. So as the CDI container boots up now, it kind of fires an event for every single bean it inspects. And who knows how CDI interceptors work? So the idea here, no one? Yeah, you should. You have a class, interceptor, and this class, by the way, we see is a priority. I make this a little bit bigger again. And it's kind of annotated with interceptor, so CDI knows, okay, this class is an interceptor, and you need something which is called interceptor binding annotation, in this case, method validated. So the idea normally, if you kind of use these interceptors, is like, whenever you want this interceptor to occur, you have to place add method validated onto this method you want to be intercepted, right? So, but that's not, you can't do that in the Bean validation case. We cannot, kind of modify your code you're deploying into the container. And you're not supposed to add this annotation. That would kind of just create all this mess. So really what we do, we are kind of observing as the container starts up each single kind of, what's the event type? Process annotated type event. And we are kind of looking at this type, and via this Bean validation metadata API, we are going, is this bean actually constrained? Are there constraints on the methods or return values? And if so, we programmatically add this annotation for you. That's how it internally works. And I guess what I want to show here is that these are the type of customizations you can do in your environment. And then another interesting bit is this part here. That's new in CDI 1.1. Before, without that, you would get an event for every single bean processed, if it had an annotation you're interested in or not. And first of all, it's kind of performance problems, and you don't want to inspect every single class. Probably only a few classes are constrained. So the idea was to introduce these annotations, and we are basically saying, I only want to get the callback if the type which is getting processed has a valid annotation or a validate and execution annotation. I leave that out for a second. And the constraint annotation. So the interesting bit is that this annotation works in a meta way. So theoretically, we would have to list here like not null, null, assert true, assert false. That's other annotations we're looking for. But what about custom annotation? We don't know what kind of additional constraints you have, so we could not look for that. But what all constraints have in common is the constraint annotation. This annotation tells Bean validation this is a constraint. Without this annotation, it's not even a constraint. So if we go back to validation extension, we are saying this annotation constraints, but what we are saying is we are looking for types where there is an annotation which contains an annotation. So it's like this meta annotation, so to say. And that's a quite powerful thing as well. Okay. And then, I don't know if that's maybe not so interesting. I go back here. So as a sample, what you can do with the extension is you can dynamically add an interceptor. You don't, if you wanted to. You can dynamically create beans. You can kind of have. So what we are doing also in the interceptor code is we are watching all the processed beans, and if by the end of the discovery no Bean validation implementation was found, we are adding ourselves as a implementation. So this allows you to maybe change the implementation of Bean validation. I mean, at the moment, it's basically Hibernate Validator, but potentially there's bval or whatever, so potentially you want to switch these kind of things. And so in this case, we are only registering ourselves if no one else has done so before. And you can dynamically switch register interceptors. If you want to try anything of these things, Wildfly, Beta 1 was released. Everyone knows what Wildfly is, I should, right? So that's JBoss renamed JBoss application server. Beta 1 is out. All these features I talked about, they are already all in there, all working, fully integrated. There are other things which kind of are not according to spec yet, but within the next couple of months, hopefully, the first at least release candidate should be out, and then it should pass all the requirements for an EE7 container. Are there any more questions to CDI, Bean Validation, EE7? None?
There's no question.
Hmm?
That's the end.
Yeah.
Do you have more? We got about like 6-7 minutes left.
Yeah, I know. I thought if there are more questions, I'm happy to kind of do that. Otherwise, we grab a coffee. We end a little bit earlier.
Okay, sure. Thank you very much for the presentation.